In this video, I'm going to be looking at light and reflection. Now, we're going to begin by starting with what light is. You've probably got a very general sense of light. Light was covered to a small extent in your grade 8 year. All light and all other electromagnetic waves travel at the same speed in a vacuum. Now, a vacuum is any well, I guess it's an absence of matter. So outer space is a vacuum, or if we were to take a container and remove all matter from it and create a vacuum, light will travel at a speed of 3 times 10 to the 8 meters per second, and we call that speed c. Please note, quite often with this section, you'll be able to approximate the speed of light through air to approximately 3 times 10 to the 8 meters per second as well, even though we in theory know it is a little bit less. It's also important that you know that light travels at a constant speed through any given medium. Now, that's saying that if light is traveling through glass, light will travel at the same speed the whole time while it's traveling through glass. It could travel at a different speed, for example, through perspex or through diamond, but it would have a constant speed for each particular medium that it travels at. And the maximum speed that light can travel is the value of 3 times 10 to the 8 meters per second, which is the speed when it travels through a vacuum. Any other speed when it's traveling through a medium will have to be less than the speed through a vacuum. Light is reflected whenever it bounces off a reflective surface. Now, most reflective surfaces tend to be shiny and they tend to be smooth. In this diagram, you can see an example of the law of reflection. The law of reflection, very importantly, says that the angle of incidence, that's that angle over there, is always equal to the angle of reflection. That's that angle over there. Just to quickly point out a couple of the things that you're going to need to be able to reproduce in diagrams similar to this one. A plane mirror is shown over here at the bottom. Now, it's very important that you understand that a plane mirror is any flat mirror plane, as opposed to a mirror plane which is possibly convex or concave. So slightly bent one way or another, a plane mirror is always a flat mirror surface. Okay, we have over here our incident ray. The incident ray is the ray coming in. So the ray of light would be traveling towards the plane mirror. The normal is an imaginary line which is at 90 degrees to the surface of the plane mirror. As I mentioned, it's imaginary, so you're not going to be seeing this as an imaginary line that we can often imagine to be put in. And the angle of incidence is always between the normal and the incident ray. It's a very common mistake that people instead think that it might be this angle over here, but that angle is never the angle of incidence. If you were ever given this value here, which we could call theta in this case, to work out the angle of incidence, you'd remember that this angle is 90 degrees, and therefore your angle of incidence in this case would be 90 minus theta, but only if you need to get to that particular value. The refracted ray, reflected ray is the ray which then leaves from the plane mirror, so it is the ray that bounces off. The angle of reflection is always between the normal and the refracted ray. Just to quickly cover all of those again, the normal is an imaginary line drawn perpendicularly to the surface. The angle of incidence is the angle between the incident ray and the normal, and the angle of refraction is the angle between the refracted ray and the normal. When we look at a reflection in a mirror, there are a few properties that you commonly see. The first thing is that the object and the image are the same size. We don't end up with a diminished or an enlarged image. The image and the object are the same size. The next thing is your lateral inversion, where your left and right hand swap. You often see this in writing on emergency vehicles. For example, if ambulance or police is written on an emergency vehicle, it will be written in mirror writing, that when you view it in a mirror, ideally your rear view mirror, you would read the writing and you'd be able to see it the way you'd normally see writing, so you'd be able to comprehend it faster. The last thing is that the image always forms the same distance behind the plane mirror as the object is in front of the plane mirror. When light is reflected off a flat surface, we get a very clear image because all of the reflected rays are aligned. So for example, over here, if I were to draw an image of what we're talking about, if that's our plane mirror and it's flat, and we end up with a whole bunch of parallel rays coming in like this. Because all of them have the same normal, they will all be reflected at the same angle, because angle of incidence equals angle of reflection, and whatever ray goes out will look like the ray that came in, so you'll see a very clear reflection. However, when light is reflected off an uneven surface, the image is diffuse or distorted. So you can imagine here that the 90-degree normal is over there for one, over there for another, and because all of them have slightly different rays and angles that are coming in, the rays initially usually come in parallel. So we'd normally even have these rays coming in parallel, but then they'd end up getting reflected, one up there, one over there, one over there, all over the place. I put in an image here of a broken mirror so you can get the idea. That quite evidently is a view of, I guess, a sunset across a lake, but because it's viewed in a broken mirror, you end up with a very distorted image. You can get a similar distorted image if you look at your own reflection in a teaspoon.